Good morning and welcome. I'm Bob Rogers, Executive Director of Coastside Land Trust, and I would like to welcome you to this edition of Coastside Land Trust free community webinar series. The Coastside Land Trust is dedicated to the preservation, protection, and enhancement of the open space environment, including the natural, scenic, recreational, cultural, historical, and agricultural resources of Half Moon Bay and the San Mateo County coast for present and future generations. We are a nonprofit organization working hard since 1997 to safeguard our scenic bluffs, open space, stream corridors, and agricultural lands from the southern city limits of Half Moon Bay north through the community of Montera in San Mateo County. Taking a strategic approach to land conservation, we protect land by purchasing and accepting donations of land and conservation easements. We secure private and public funding for land conservation. We provide assistance and resources to landowners interested in protecting their land. And we lead local conservation, restoration, stewardship, and educational activities. And every day we remain dedicated to protecting our coastline and our future. As members of our community and valued Coastside Land Trust supporters, we ask you to make choices that support our organization and our important work. This can be done by donating through our website. Other easy ways to donate are through planned giving of assets through land wills and living trusts, vehicle donations, gifts of stock, or tribute gifts, also showing up for work days and passing along our message and our mission. The important part here is that we all do our part in whatever way we can to protect and steward our shared open spaces. Thank you for joining us here today. And it is my pleasure to turn it over to Kate Dickey, our social media coordinator, to introduce our presenter. Take it away, Kate.
Thanks, Bob. Good morning. We're really excited to welcome you all and welcome Doug Millar, who's the project manager for the agricultural program at the San Mateo Resource Conservation District, which is focused on compost and soil health projects, is his domain. Doug has worked in San Mateo County agriculture for over 15 years, including at TomKat Ranch and the HEAL Project. He brings 25 years of experience in agriculture, composting, soil health, and carbon farm planning. He grew up in the middle of the farmland and graduated from Ohio State University in greenhouse production and management. But his passion for soil and surf makes San Mateo County his ideal home. So today we hope that you will enjoy this presentation as Doug Millar shares with us about compost here on the coast.
I'm very grateful for you all to join me today, this morning, on a Saturday morning to learn about compost. There's lots of things you could be doing, and I'm so grateful that you joined me here. So compost on the coast, let's get started. So I work for the San Mateo Resource Conservation District, and I wanted to share a little bit about that. The Resource Conservation District is a public agency that exists for the purpose of helping people help the land. And born out of the Dust Bowl in the 1930s, when the government realized that soil is our most valuable resource, we are almost entirely grant funded. So we operate more like a nonprofit, and we work primarily in the western half of San Mateo County. We were started in 1939, and we help any kind of partner best manage their natural resources, whether it is water, wildlife, climate change, agriculture, forest health, fire and resiliency. We're there to help, and we work with farmers, ranchers, homeowners, landowners, the counties and cities and advocacy groups. We work with anybody who wants to do voluntary conservation to best manage their natural resources. So we help people connect with the financial, the technical assistance, and educational assistance to conserve natural resources. So I want to tell you a little personal story about me. You know, I went to Ohio State, I studied greenhouse production and management, and for the most part, I learned that it's, it takes about 17 elements to grow a plant, and you can do that without soil. You can, there's a whole process like hydroponics that makes that possible. And so I happen to be at the, several years ago, I was the sales and marketing manager for a very large fertilizer company. And I met this guy, I started working with this guy named Jeff Lowenfels, who wrote a book called Teaming with Microbes. Great book, really good to read. And in that book, he has something that really blew my mind and made me change my thinking forever. So in that book, there's an electron microscope photograph, and I've kind of blown this up, so I apologize. The text is a little fuzzy on the side there. But this is the picture of a root nematode attacking a tomato root to feed. Now, that's a pretty common thing that happens. But when we look at this next picture, here is a root nematode being trapped by a fungal hyphae. So how did this fungus know to trap this nematode and protect the plant? Why would it even care? What incentive does it have? Well, photosynthesis is the reason for that. So with photosynthesis, I think we've learned, in school when we were kids that, a plant takes sunlight, CO2, and water, and it makes glucose and sucrose, which is sugar, right? So sugar. And then it takes those sugars and it rearranges them into longer chains to make leaves, roots, shoots, and fruits. And then the sugars that are left over after all those plant parts are made, there's about 30 to 40% of those sugars are leaked out the roots. And those roots, the leaky, carbon sugars are traded for nutrients with mycorrhizal fungi, bacteria. So like the fungi can deliver phosphorus and water. These fungi can really reach out like almost a mile away from the plant practically. So they can reach far distances like a root extension. And then the bacteria, they can help deliver nitrogen. And so this is how it works. And this is a way of like a marketplace in the soil. And what's neat is when all of that carbon gets into our soil, we can sequester carbon in our soils. So photosynthesis could be an answer to drawing down carbon from our atmosphere. It is the answer to drawing down carbon from our atmosphere. So soil consists of about 45% mineral, 5%, maybe give or take, a few percentages there of organic matter. And then the rest of it's pore space, which is really important. So when we look at a clump of soil like this one here, you can see these little tiny aggregates. Those are the tiny clumps that are in the bigger clump. Those tiny clumps, as they fit together sort of irregularly, they create porous pipes and pathways for microbes and microarthropods, really tiny insects, worms, to move around. It also creates the ability for the soil to allow for water infiltration and air infiltration so that the microbes can stay happy, moist, and oxygenated so they can breathe. And so soil organic matter has about 58% carbon. So those leaky roots sequester a lot of carbon. And that must mean that we could use agriculture as a way of reducing greenhouse gases by sequestering carbon in our soil using photosynthesis. So in 1 square meter of soil, there's so many microbes. There's millions and millions of them. So what do we do to protect those so that they can keep feeding the plants and sequestering more carbon? Well, there's plenty of practices that do that, but we have 4 principles of soil health that help the soil stay in that soil health zone. So we have we need to minimize the disturbance. So try to reduce the tilling. Every time we stir up soil, it exposes microbes and other soil carbon stocks to the atmosphere, which then they eventually turn into carbon dioxide, which is a greenhouse gas, heating up our planet. So that's one way we want to just kind of keep the soil in place. Then we maximize the biodiversity. So we get more species of plants, more animals, and all of that helps create more of that marketplace under the soil that I was just talking about with photosynthesis. And then we maximize the soil cover. So we protect the soil. So we want to keep it so that the sunlight is not hitting bare ground. Bare ground is like the worst situation we can have because sunlight hits the bare ground, it reflects, it goes back up into the atmosphere, warming our planet as it bounces off that thick layer of greenhouse gases that we have. So covering our soil is really important. and then maximize living roots. So if we have like living cover, like a cover crop, well, then we have a nice protection of our soil. And we also have these roots that are constantly feeding the soil with those root exudates, those sugars that leak out of the roots I mentioned before. So there's lots of practices that we can use, and here's some of the practices we use in what we call carbon farming. And carbon farming is a way of looking at a ranch or a farm through a holistic carbon lens. So we're looking at it just how do we use certain practices to maximize and optimize the carbon on a farm or a ranch so that we can keep building our soils and keep sequestering the carbon and reducing our greenhouse gases. So there's things like cover crops, which will protect the soil. It's a nice living root. It also provides nutrients like nitrogen. And it also helps with water infiltration and slowing and spreading the water so it infiltrates, more evenly. Then there's rotational grazing, where we're using animals to have a specific impact, very intense impact in one spot, and then the animals move on, and then the rancher doesn't come back there for as long as it takes for those grasses to recover. And when that happens, the roots start to reach down further and we get more root exudates and we start to build our soil organic matter. It's a really wonderful tool when used. And then we have reduced soil disturbance, which is, less tilling, trying to keep those soils carbon stocks in place. And then there's compost applications. Hey, we should talk about that some more. Compost applications have organic matter. There's also nutrients in there, and they help with the microbial populations of replenishing those. So it's just kind of like a nice jump start to the biology. And then windbreaks. Windbreaks are a nice way of protecting the soil from wind. So wind erosion, can really blow off your soil or dry it out. So that's also another really great way of sequestering carbon. Plus, those trees themselves are filled with carbon, so they're also a carbon stock. Then there's mulch. Mulch is another practice that helps, slow and spread water as it's infiltrating, and then it also protects the soil from the sunlight and keeps the moisture in as well. So it's another great armor for our soil. And then grassland restoration. We use grassland restoration for reintroducing native species that may have been outcompeted by the annual grasses that were introduced by Europeans way back when. So, just restoring the natives and getting more habitat for native pollinators as well. And then, adjacent to that is the pollinator habitat. So planting hedgerows and strategic plantings so that there's a bloom going on all year round for pollinators to continually habitate that plot of land. It's a really great way of keeping your biodiversity. So carbon farming, like I mentioned, is looking at a ranch or a farm through a carbon lens. And there's all these carbon farming practices that have co-benefits. They're all related, right? So there's this entourage effect when you do, a couple of practices together or all of them. And it just creates so much good on your ranch and farm that it's great when you can combine these practices. But even one all on its own can be very powerful. And compost is one of those. So what is compost? I thought it'd be a good idea to have a definition for us all to just, work off of for this presentation. So composting is the aerobic or oxygen requiring decomposition of organic material by microorganisms under controlled conditions. So what is compost made from? Well, it's made from feedstocks. Feedstocks is the industry term for organic stuff that's going to break down. So food waste, yard waste, manure and stable waste, just about anything organic, right? But where do feedstocks go when they're not composted? Well, unfortunately, they go right up in the atmosphere as methane, and because they break down usually anaerobically. And so methane's 24 times worse than carbon dioxide. So that's not good. So keeping materials out of the landfill is a really good idea because, honestly, our landfills are going to be landfills and we're going to have to start over. So if we could keep the stuff that doesn't need to be in there, we'll at least keep those landfills going longer and not have to start new ones. And we can see that this is true by the carbon dioxide concentration in our atmosphere continually raising over the last 40 years. It's been raising for longer than that, but this is what we have for our for records. And that's why we need more photosynthesis. And how do we do that? Well, we can use compost and really get it started. So why do we add compost to the land? We increase soil health and structure for better water infiltration by adding compost. We increase water holding capacity. It helps increase photosynthesis, drawing down carbon dioxide from our atmosphere. And then it adds organic matter, which is like soil glue. So that helps prevent erosion, and it just keeps everything together for those microbes to be pretty happy. So what makes a good compost? Well, the feedstocks composition is really important. Just like any ingredient for your recipe that you make for dinner, it's a good idea to have the right ingredients. And then the compost method, certain compost methods are really ideal for certain materials, and others, they could be done a better way. So we'll talk about that. And then how materials are handled pre and post compost process is pretty important. You can see here, by keeping it covered, this goes both for feedstocks and finished compost, you can prevent, like if there's rain falling on this pile, if this were, let's say it's a pile of manure or it's finished compost, if the rain falls, it's going to leach nutrients. Nitrogen, phosphorus can very easily leach out, and then those could go to our waterways or in our groundwater. And that's not good. That's pollution, but also it's not good because then the pile loses that. And that's valuable nutrients that we want to retain. So by keeping that cover on there, it also helps keep the pile moist so it doesn't get too dry. Trying to re-wet a super dry pile takes a lot more water than it needs to. So keeping it moist is a good thing too. And then here we have the composting basics, the ins and outs of compost. You've got oxygen, water, microorganisms, and then the organic materials for the feedstocks. And then off of that, we get water vapor, a little bit of carbon dioxide, a lot less than what was sequestered through the just through the plants photosynthesizing. So that's okay. Then we have some heat, and then odors and other gases occur. If that's one good way of knowing that my compost pile is not quite right. It shouldn't stink too much, right? If it's done correctly. And there's compost. Then you get the compost. It's a nice stable organic matter. It's filled with minerals and microbes and just really good for your soil, right? So feedstocks, let's talk about those really quick. The basic terminology composter is used is greens and browns. And greens are grass trimmings, food scraps, manure. These are things that have more nitrogen in them. And then there's browns, straw, mulch. They're more woody materials, and they have more carbon in them. And so they break down a lot slower. So you can see here from most degradable to least degradable, the things that degrade the quickest have the more sugars in them and more nitrogen. So those things are at the top of the list. And then as you go down, the tough stuff where there's more carbon, that's the woodier things, and that's takes a lot more to degrade. So how do we figure out how to mix these materials so that it's like the right recipe? Like what's the way of doing that? Well, we look at something called the carbon to nitrogen ratio. And that is basically just how many carbons there is to nitrogens, right? So things like the woody materials, like sawdust, has a 400-to-1, wheat straw 80-to-1, and then you look at the finished compost and it has a 15-to-1. And then the microbes themselves have a 10-to-1. So a compost pile range for composting, you can get away with anywhere between 20 to 60-to-1 carbon to nitrogen. But the ideal range is 25 to 35-to-1. But why is that? I always kind of struggled with that. Like I heard these numbers and I knew I needed to mix them, but I just always wondered, like, well, what's the reason for that? Well, the reason for that is because the C/N of microbes is about 10-to-1. And so their food should be 24-to-1. And the reason for that is because it takes 8 parts of carbon to maintain their little bodies, and then it takes 16 parts of carbon just for their energy. So that's the 24-to-1. That's the whole reason why we need that compost pile range to be near there for them to really, gobble up everything and keep it going. So what's really amazing to me is that compost is both food and housing for microbes. So then the structure and porosity of the pile, well, this is their house, right? So we want them to be happy and breathing nicely. So we have this nice little diagram from the composting handbook that shows like a compost pile with thin film of water around it, or, particle with thin film of water. And then there's the airflow, the air spaces in between there. And we need about 40% free air pore space to really keep the microbes happy. And then there's moisture as well. That's another factor in composting. Can't have a dry pile, it's not going to compost. The microbes aren't moving. So having the ideal moisture between 40 to 60% moisture is what you want. You'll squeeze it, for the high-tech test here, you just basically squeeze a ball of compost. If it stays together and one drop comes out, it's about 50% moisture. And then temperature. Temperature is pretty important too. So at about 131 degrees, all of the pathogens, the bad guys, the bad microbes, they're dying off. The weed seeds that might be in the pile, they're dying off. So they're not going to, sprout new weeds. So at that point, at 131 or 130 degrees, it's a good idea to turn the pile so that the parts that weren't 131 can now be in the center, and that way they'll start to get rid of the weed seeds and the pathogens. And then if you let that tile get too hot, it could kill everything. Like then you're resetting. So you don't want to kill the good microbes because they'll die off at the higher temperatures. And they can, depending on your carbon to nitrogen ratio, you can get a compost pile to get up to, like 180 degrees. So you don't want that. So it's better to have it, cooling off back to staying at that consistent 130 until it's just totally finished, or totally finished being at that level, and then it'll cool off slowly. So there's many types of compost systems, and I thought we should talk about that because composting gets confusing. There's so many different types of systems, and then there's all these different materials, their C to N ratios, and some things are really wet, some things are really dry. So that's why I want to go through all these just so you can get a good sense for what is the most appropriate. So we have a 3-bin system, a constructed bunker, passively aerated compost, aerated static pile compost with air, in vessel, turned windrows, fermented compost. Whoa, fermented compost. And then electric kitchen composters, vermicompost, with worms, and then community composting. So, and then large scale composting, kind of like, like a municipal system. So our 3-bin system here, you can see there's 4 bins, but the 4th bin over there isn't for composting, it's just for staging, is a pretty common system. You fill it up, here, and then as it fills up and then it starts to compost and it gets to a temperature, like 131 degrees, then you could open up this lid, remove these slats, they just slide out, and then you can scoop the compost out, put it in here, and that kind of acts as a turn, right? And then you can start over in this bin here. And then as that second bin, again, that material that you had just turned, as that gets, to a temperature again, you may want to put it over here as a turn, and then you just keep shuffling stuff. That's one way of utilizing a 3-bin system. And then here's another system it's a constructed bunker, but it's really just a big 3-bin system. But what's neat is that it's, it's covered, it's got a dedicated cover, so you're not going to have any water in there to leach nutrients, and you can get like a big forklift in there to turn the material. So there's a little more access to it there. Then passively aerated stacked piles. These are neat because they're sort of a set it, wet it, and forget it compost system. So they're utilizing this hog wire stuff, or you could use fencing or any kind of mesh. And then this is, just some weed barrier fabric, just to hold the compost in that mesh. And then what they do is they just basically make kind of a lasagna of different materials layered on top of each other, where they mix it up. And then they stick these pipes in here that have perforations in them. And then those pipes help with the passive aeration of the pile. So there's microbes in there that need to breathe. And what's really cool about this system is that because there's no turning, you may get a higher fungal to bacteria ratio at the end of the compost than you would with a turn compost, because fungi, they tend to, well, they do grow in like a filament. So there's these little branches, and every time we turn them, they break up and then they have to regrow, and that takes energy. So having longer filaments when you're done, well, then those big chunks, when you add it to your, system, whether it's perennial grasses or, some woody plants that prefer more fungus to bacteria, well, then they'll have a better chance when they get to that instead of getting broken up all the time. Then this system is just really amazing. I'm really advocating for this kind of a compost pile system because of its low labor and really good finish. It's called an aerated static pile. And basically, it's got a jumpy house blower here, and it pumps through this blows air through this manifold. And then through these pipes underneath the pile, they're all perforated, and they, blow air up through the pile. I think it's like, every couple of minutes for probably like 30 seconds or something, but it's usually set on timers, and it's set up, so basically when the pile gets to the temperature that the air kicks on and cools it back down and keeps the microbes going. What's fascinating to me is they actually take the composted material, put it directly on the pipes. So, that's really efficient. Like, if you're scooping up equine waste and having to put it in a pile, well, why not put it on a pile on top of pipes? Then it reduces by like 50%. So now when you move it again, you're only moving like half of it. Plus it's compost. So people want that. And then you're only trucking like half of the volume that you started with. So that's also a labor saving. And then the labor savings of not actually turning. But what's cool about this system is on this pile is about a 12-inch layer of finished compost. And I think that's a really awesome approach, because what it does is you have the compost pile of uncomposted material, and then this blanket, which provides a microbial pressure on the edges of the compost pile that don't always get the temperature. So now with this blanket, they do, and the microbes are working from the outside in and the inside out. So you get a really even composting process through this aerated static pile. I think this is awesome for a lot of different materials, particularly equine waste. And here is another look at that pile and the pipes underneath. It's ideal for many feedstocks. And then there's an in-vessel system where it's just basically, like it says, in a vessel. So it's in this, large container that you put food waste in one side. Usually this kind of system is made for the gross stuff, like food scraps and just really wet things that are gonna putresce. Putresce means just get really smelly and just so that goes into the system. There's a computer that controls how quickly it moves through the system. There's air and water that's mixed in, the material is mixed up, and as it slowly goes through the system, it comes out the end as a quasi-finished compost. 14 days is not enough to actually compost something. It's kind of like, trying to grow a baby in 2 months. You just can't. So there's going to be some more time for it to cure. So composts need to sit for about 90 to 180 days after a system like this. But it's a really great way of processing gross stuff. And you can move this material anywhere and it's not going to be all smelly. So that's really a great system. This is another look at an in-vessel system done by Green Mountain Technologies. And it's in this more of a box type system, but the same thing. Then there's turned windrows. Turned windrows are just, a windrow is a long compost pile. It's a pile next to another pile and connected, so it's one big long pile. They use a windrow turner. That's what we're looking at right now. And the windrow turner is to turn those edges of the pile. That's the toe of the pile. The edges basically don't get, to the same temperature as the center does. So the idea of the turner is to incorporate those edges back into the center so that they compost more. Oftentimes people will say the turning is to oxygenate the pile. I mean, it does do that, but that's not the actual reason for it. The oxygen is depleted or used up, in like 30 seconds. So it's really just to get that uncomposted material into the compost zone, like the meat of the compost zone, the heat. So then there's fermented compost. That's like, like kombucha compost. Yeah, basically. So they use a different inoculant, but it's a really interesting way because there's no turning involved. So that again might mean more higher fungi to bacteria ratio. And they use an inoculant of anaerobic microbes. All the composting I've been talking about is aerobic, oxygen present, microbes that breathe oxygen. Well, this is anaerobic, so they don't need the oxygen. And so basically they spray it down with this inoculant, and then they seal it up as much as possible to keep the air out of it. And then, you wait like a year, and then you check it out. It can compost just about any material. So that's cool. So even if you had like, meat, bones, fish, whatever, that's a good method. And it's just a method that got to have a lot of space to use it and the willingness to dedicate that space to it. Then there are electric kitchen composters, and those are recently on the scene, and I was pretty excited about those. But when I read the instructions and things, it's like, you get compost in 4 days, but you can't get compost in 4 days. So after doing some more research on the ones that I was looking at, it's kind of like a dry and grind. So it dries the food scraps and grinds them up into bits. And those bits are great for a compost system or a worm system. The thing about it is that, it's removing water from the material. And then when you take that material and put it into a compost system, you have to water it again. So that's kind of like a waste of water, but it would work really awesome if you use that in conjunction with a worm bin. So this is a vermicompost operation that I had a while back, and this is me feeding the worms. Well, actually, interestingly enough, these food scraps are feeding the microbes, and then the worms actually eat the microbes. So the worms don't really eat this stuff. They eat the stuff that ate that stuff. And this is an elegant system. I know it just looks like some wood in a box and some horse manure and food scraps, but it's called a continuous flow through reactor. And you can look that up. Those systems are engineered typically. This one is a do-it-yourself. And basically it's a box with a grid at the bottom. I use 2x4-inch hog wire for the bottom mesh of it. So what's cool about that is, there's air down there, there's air up at the top. So there's just a little more air in the system. There's no leachate collecting. Worm systems oftentimes have like a solid bottom, and then you get that salty, anaerobic, wet leachate layer that the worms hate and want to leave, and there's a lot of ammonia. That's the worst situation for a worm. So having an open bottom is a much healthier system. And then what's cool is that the weight of the material pushes the castings out that mesh, and then you just shave the castings off. So that's how I collected or harvested the worm castings. It's pretty awesome. Then there's community composting. So this is a great solution to keep organics out of our landfills. It also provides, community, people get together, do things. The thing about community composting is we oftentimes have volunteers. So it's not always monitored regularly because everybody has different schedules. And so sometimes we want to make sure that, if there is some irregularity in the monitoring, we would want to just test it for pathogens. The material would be ideal for ornamental gardens, but if we would want to use it for food gardens, we would want to just, pay for a pathogen test just to make sure it's evenly composted. And then here, lastly, for our compost systems is a large facility. And you can see they have those same windrows here that I was showing before. And then they have these bagged systems, which is pretty neat. This is also an aerated static pile. And I was always wondering, well, why do they put it in the bags? Well, it's because most of the time it's really gross, food scrappy stuff that's going to get all putrescent and stinky. So you put it in there, and all the neighbors are a lot happier. I drive past this place all the time. It's not stinky. So pretty neat system. So here's a system where I wanted to show you how they screen, places will screen compost. This particular is a municipal facility, not the one that we were just looking at. And they had a lot of trash in their compost, so they needed to screen it. This does come out pretty clean, but it's a process that, if we could keep the trash out of our green bins, they wouldn't have to do this as much. Pretty neat system though. It's called a trommel, and it uses these little brushes here to just keep the material back in the screen. It's just a big tube screen, and you shove compost and it rolls around and then spits it out on the conveyor belt and then into this pile. Whoops, start it again. So where do we add compost? Well, there's a lot of places in this world where we could add compost due to the fact that there is just depleted organic matter. Even in our own county, there's lots of depleted organic matter. Back in the World War times, the federal government encouraged folks to plant flax and hay, and the uplands were tilled, lots of areas were tilled, and we lost a lot of organic matter that was naturally there. So replenishing that with compost would be a great idea. However, it's really important to us to make sure that we're not just broadcasting compost all over the place without giving it some thought. And so I like to do a nutrient budget for sensitive areas. These areas, it's important to do soil sampling. Just make sure that we're not applying too much nitrogen or phosphorus, and just being really, aware of that. And so there's also just like the carbon to nitrogen ratio of that material. In a rangeland system, I would use a higher carbon to nitrogen ratio, because a rangeland system doesn't need much nitrogen, but it's a really good system to have carbon in. Whereas, in an agricultural system, maybe we want to cut down on the nitrogen fertilizer, so we would want more nitrogen in our compost. So there's a balance there, and we just want to be very responsible with that, and that's our goal. So places we can apply compost, well, farms are kind of an obvious one. And then the rangeland, like I mentioned. So for rangelands, it's a one-time deal. You apply compost, and you don't need to apply it for like another 30 years. I say that because the Marin Carbon Project did a project where they have been testing year after year, where they applied just a thin layer of compost, and the models are showing that it will keep sequestering carbon for up to 30 years. It also jumpstarts the biology and really gets the grasses growing. So there's also places like county parks and golf courses. These are green spaces that do get fertilizer, and they don't necessarily need to get that. They could get compost, replenish the organic matter in the soil, and also, rejuvenate the microbial populations. And I used this campus here. It's on the bay side of our county, and I just took all the green spaces, drew these polygons, and calculated the acreage. And then I figured out that we could apply 30 to 100 tons of compost every year just on this campus. There's lots of scenarios where we could do this all over our county. And what's neat is when you apply compost, even at 10 tons per acre, which is like an agricultural rate, we could do it much lower for the campuses and golf courses, like 3 to 5 tons. And you can see it's disappearing in this grass. There's some chunks, but we can get rid of those. But that's what's neat, is we could apply compost just about anywhere and it will disappear. So things like roadsides and medians might be a great idea to increase the water holding capacity of those soils. So maybe we won't get so much fire. Then there's stormwater control, like bioswales. Bioswales are for, for water to, collect when there's possible flooding. Well, if you have compost there, 1 gallon of fine compost holds 4 gallons of water. So what if we could increase the capacity of this bioswale by like 4 times? That would be a huge improvement in case there's any, massive flooding things. So that's another tool we could use compost as. How do we add compost? So how do we get it on the ground? Well, there's a lot of different methods. We can use compost filter socks to capture sediment and nutrients and pollutants that may be running off from a construction site. We can use slinger trucks to sling compost into a place where trucks may not be able to get. We can use compost blower trucks. That's also another precision compost application. Let's if you've got a slopey hill like the one in my little background behind me, couldn't take a truck up that or a tractor and a spreader. So we could use something like that. Then there's the compost delivery. It's delivered in a double side dump trailer. That's got 24 tons of compost here. And when we deliver these composts, it sure does make happy farmers, and we love happy farmers. So the farmers would use, if they're going to spread it themselves, they'll use a tractor to pull like a manure spreader, or we'll have a spreader truck go on the farm. It's a big farm. And this spreader truck, it's like a big dump truck, right? And then it's got this little conveyor belt here. It brings moves the material out onto these spinny plates that spreads the compost pretty precisely, actually. I'm amazed that these guys can get when I suggest an application rate and I see how evenly it's done, I'm really impressed by their work. Here's somebody spreading on a disc field. This is a farm. And then here's a rangeland application. You can see them out there. This is a dry time of year, so there's less impact on soil compaction. And here again, this is, we'll do this and we won't do it again unless they want to do it in 30 years. And then proximity to compost. So we have all of our farms up here, right, in our county, and all the compost facilities are down here. Well, that's a drag because we have to drive compost all the way up to our farms. I've done the carbon footprint. It's still a beneficial thing for us to do. It's still positive. It would be a whole lot better if we had compost facility in San Mateo County or a distributed network of compost facilities in San Mateo County. We'll talk about that in a second. So SB 1383 is a law that the state recently passed, and it requires every city, town, and county across the state to procure a certain amount of compost, mulch, or renewable natural gas annually. And the quantity of product is dictated by the jurisdiction's population. So their population says like what percentage or how much they need to procure of these materials to offset the to divert organic materials from going to the landfill. That's the whole idea of the law, is to just jumpstart the compost economy so that we can start diverting more organic materials from the landfill. And by forcing cities to purchase compost or those other materials, that's the impetus for doing that. Now, there's only so much compost that a city can actually take, give away, and spread on their land. So where else can it go? Well, that's when we at the RCD had a pretty good idea to suggest to our local jurisdictions in San Mateo County. We said the Resource Conservation District has relationships with many of the farms and ranches in our county, and we know that many of them use compost already, and that some of them don't use compost just because it costs too much. So we proposed that we could help with 1383 by starting the San Mateo Resource Conservation District compost program. So we help connect farms and ranches on the coast side with the bayside cities so that everybody wins. So a farmer can get reduced cost compost. We pay 75% of the cost of delivery and spreading of that compost. And then the cities and jurisdictions get the credits for their requirements for 1383. And so with the RCD compost program, we sign farms up, then we do soil sampling, then we order and deliver the compost, spread it, and then we verify that the practice actually happened, and then we report that to the jurisdiction. And in this, you can see this is pretty cool soil core that we pulled. And you can see here, there's the organic matter. Those are the roots. We're leaking out all those yummy sugars, and that's where all the microbes are. And then down here, not so much carbon. But all this dark stuff, that's carbon, right? So we do a soil analysis report just to double check. We look at things like organic matter, like that's at 2.5%. That's pretty low, so he definitely needs compost there. But then we also want to look at, what's their nutrients and how much compost we would want to apply to make sure that all the nutrients stay in the right zones. That's why we do those soil analysis reports. And then we have some ideas for the coastline. So one of the ideas is we need a compost facility. I think I pointed that out earlier. So it would be great if we could get either a distributed network of compost facilities, like some on the bay side to handle some of those, the jurisdictional, the more population stuff. And then definitely on the coast side, we have all sorts of other organic materials, agricultural, lots of wood chips, lots of all sorts of things, right? So by having a distributed network, that means less trucking. And I think that would be a good system, but that does mean more management. So there's trade-offs. I mean, we should hopefully have a discussion someday with lots of people to help decide these things. Then fish and chips, right? So we're on the coast and we have all these downed trees, hazardous trees from fires that were recent and also the storms that were recent. And we have to chip all that stuff up. And all the material is like, we have lots of it over just in Half Moon Bay, El Granada area, right? And then from the eucalyptus trees. And then we also have our harbor, which, is lots of fisheries. And so there's going to be the fish offal, the heads, the guts, the tails, and all that, those bits and pieces after they process the fish. Well, that's got to go somewhere, right? So what if we took all that stuff and mixed it all up into an in-vessel system so it doesn't stink, right? That's not gonna smell good, right? If you don't do it that way. And then we put it in an in-vessel system, we create awesome, rich compost, and we can give that away or do whatever we want. But now we're processing those materials. We're using local organic materials. We're not trucking them anywhere. They're turning into a valuable product. It just makes a lot of sense. I think we should try it out. And then equine waste. Now, I apologize. We've made it 75 slides or so through a compost presentation without looking at any poop. But right now, we're talking about horse manure, horse buns. My dad used to call them road apples. It's crazy that we use things like, even use terms like cow pies for manure. It's like, why are we using food items to describe these materials? I don't know why. But equine waste is often called compost, coming straight out of the horse. And I think that's a soft way of calling, it manure, but it's really still just manure. Equine waste does have, I think it's about 30-to-1 carbon to nitrogen ratio, but then the shavings or bedding have a much higher carbon to nitrogen ratio. So it's something that oftentimes gets put out on land uncomposted, which is okay. But those, the manures, they're not, they're going to leach out stuff and it's not really locking away, stabilizing those nutrients. And then the shavings, the bedding material stays around for a lot longer, which can help as a mulch, it sort of acts like a mulch, but it takes more work for the soil to break that down. As if, instead of if it were compost, then the soil wouldn't need to break it down. And so it's kind of like, I think about it like this, is if we put it down, raw, uncomposted, then we're sort of asking, like if we were building a house, we're sort of asking the demo crew to build the house. Maybe there's some of the same guys on that crew, but they're not going to have the same skill set as the builders of the building the house. So I like to look at it that way. So if we have composted horse manure, the house is being built. It's already there. That is the house, right? So it's food and housing, as I mentioned earlier. So I think that's a great opportunity. And also because we have so many awesome equine owners, we could utilize this material. They could scoop it up, put it on an aerated static pile system right at their site, like in the same spot that they normally would pile it up, and just let it compost there. And as I mentioned, now they're moving 50% of the material. They didn't have to turn it because that's more labor. And by moving only half the material, that's going to reduce the trucking cost by half if they were going to move it off their land. But because it's a valuable material now, it's compost, it could either be sold, it could be reapplied on the land in the pasture. The pasture will love it. The horses will love it because they won't be walking around in their own stuff too. So I think it's a good thing. I would love to have more conversations with equine owners. I don't know everything about it, so I'd just love to, talk about the process and see if it would work for you. And so reach out if you'd like, because I think there's going to be a lot of opportunities to do more aerated static pile systems. There's a lot of developments. There's even a local guy developing an open source control system for it. So we'll stop looking at that slide. Then there's landscapers who could distribute compost. When we think about landscaping, landscapers clean up our yards, make them look really nice, but they remove a lot of carbon. In this situation, this tree is dropping leaves. So those leaves are filled with carbon. And if they stayed put, they would feed the soil. The soil microbes would start to reach up and break them down. And then that would becomes more of the feed for the tree, right? It's kind of like in a forest. There's lots of compost on the forest floor, but if it gets raked up and trucked off somewhere, well, it never returns. So I think it would be an awesome system if we could set up a system similar to the compost program where we help farms and ranches, helping landscapers access compost either for free or for a reduced price, to help deliver back the carbon that was taken off. So we could return the carbon to the landscape, and your landscape would be healthier. You would water less because your water holding capacity of your soil would increase. Plants would be happier, your trees would be happier. I think it's a good system to do. And then wrapping up, I just want to say, remind you that there's many ways to compost. The feedstocks do dictate the final product, so we want to be careful about our recipes to make sure that it composts optimally. And then SB 1383, that's the law that helped us develop the compost program for the Resource Conservation District and all of our local farms and ranches. And that's just jump-starting the compost economy and getting us all talking about things like compost facilities. And then farms and ranches are taking this opportunity to regenerate their depleted lands, and it's really great to see. And then lastly, let's just get more composters and let's talk about a compost facility. I think we can do it. So lastly, I just want to close in saying that, how we manage plants and the relationship with microbes is what builds soil. This is a quote by Dr. Christine Jones. She's done a lot of amazing work with this whole movement of photosynthesis feeding soil, and I just want to say that it's really rewarding work. We got lots of rewards like this. And lastly, compost is the word of the day, so let's spread the word. Thanks a lot.
No, thank you so much, Doug Millar. We're so grateful for this presentation. Gosh, so much to think on, so much to kind of action. I think a number of people are asking questions about action that they can take. And I know your last slide hit it. A few of you have typed in some questions, and I think you had, Doug had given us the opportunity that we'll be able to answer a number of these in a follow-up email. Is that true? But one of the questions that someone asked, I think would be a universal question, is how you think that, how can we help? What are the best first steps? And you just referenced that in your slide, but just how can we be the most helpful in getting the compost facilities more localized?
Yeah, I think, getting a good handle on just the organic materials that we're generating in the area. Some places have the green bins, and those are great, and that stuff gets trucked off someplace. But when you don't have a green bin, where does that go? So unincorporated county doesn't necessarily have that service. So that's one place where I think, down near Pescadero area, we might want to look at, a spot for composting near the transfer station, the quarry, something like that. So getting community support for that would be great. And then also mid-coast, maybe we work with the local landfill. They could do something there, or there's somewhere else, or, just if you're an equine owner, reach out. We could talk about aerated static pile systems, or if you're, got like a boarding facility, that's another really great opportunity because there's so much equine waste there.
And if people are interested in working with San Mateo Resource Conservation District in terms of using that compost, is it best to just reach out to San Mateo RCD about that?
Yeah,
Obviously not at a
so
home
with our
level
compost,
facility.
yeah, it just depends on what, how much compost you need. The program that we run is, for a more, like 12 tons minimum. That's a lot of compost, but that's because the truck carries 12 tons. But there are local sources of compost that I know of, and I'd be happy to connect folks with that. And I think that just gets things moving. The more we start talking about it, the more we access this stuff, more people pop up and say, oh, I can do this, and or I have this material that needs composted. I visited an alpaca ranch recently, and he was like, I'm trying to give this stuff away, and I was like, oh cool, I see. I have a ranch or a farm that may want that. So it's just a matter of making connections and building that community, and then eventually we find a way to do this.
I know a number of schools, both with the Junior Land Stewards program and a couple of other schools in this area, that would benefit a lot from connecting and helping to be part of the link with that as well. All right. Well, there are a couple of other questions. Let's see. We have Eric was one of the first ones. He was talking about in his compost bin. He was saying that there's a lot of these white roots that are growing throughout his compost. He said it looks like these thick white roots. Can you speak to that, if that's a bad thing?
Yeah, that's probably actinomycetes. Those are like long filament things. They're not like really roots. They're just kind of, looks like gray, like white gray kind of. I'm not sure if that's what you're describing, but that's what I see in compost piles. That's fine. That's fine. You might need a little more aeration or structure to your pile, but it's okay.
Okay. And you were talking a lot about coverage, but in your continuous flow through worm bin, Nancy was asking, did you cover the food scraps after you added them?
No, it's I had a light on. So worms don't like light. So they wouldn't escape the bin. If I turn the light off, then they just kind of go all over the place. But if I kept the light on, then they stayed in that spot. And then the microbes, that's just kind of like food scraps. The microbes broke that down. I didn't have to cover that because it was already in a like a shed, or a building.
Okay.
So it was already covered.
Nancy asked, in the passively aerated static pile you showed, did you take the pipes out as in Johnson-Su method, or did you leave those pipes in, and how long did you leave them in the compost?
Yeah, they were left in the whole time.
Okay.
But that's trying to mimic the Johnson-Su. Yeah, but I know that they took them out.
Jan asks, is there a danger in introducing the exotic organisms into the soil by using inoculants and vermisystems? Saying, soil ecology is really delicate.
Yeah, right. So exotic things, well, most of the materials are coming from the local area, right? So they're already, local, but there are invasive plants, and so that's why it's really important to monitor your compost system so that it's going to heat up and kill the pathogens, and that's and weed seeds, and then you don't have as much of that worry. It's really important to, like I mentioned before, with the nutrients we test, it's important to maintain soil ecology and make sure that we're not messing up the system. But in general, we've not seen that experience. And I work with like so many universities, and I have a pretty robust network, thankfully, that ask all these questions when I need to ask these questions. And I'm always concerned about that stuff. I don't want to mess anything up.
Okay, and then Nancy was asking, is the compost being tested before applying to the farms? Is it being tested for PFASs, herbicides, microplastics, things like that? The larger scale.
Absolutely. Absolutely. Again, that's part of the responsibility of, adding any input to any system is to make sure that it's appropriate and that it's not contaminated. And that's what's great about this law is it actually it's diverting organic materials from landfill, but it's also jumpstarting these conversations about contamination and plastics. And I've actually participated in some microplastic studies of the various composts that we're using to identify which one's the best, who has it, who doesn't have it. And so we've done that. And then there is an industry standard for compost facilities. They have to test for all the other pathogens and other, it's very rigorous. So it's important to make sure that we use certified facilities that are responsible and have to do that.
Amy says she's currently looking at a field of mowed weeds. Can I, and she said with seeds, can I use it in compost if it achieves 130 degrees?
Yeah, you can. I mean, that's bold, but it should work just fine, right? Typically, seeds are going to get out there. If you've got just a bunch of seeds, I do say that's both just because, something could slip past. So if you're going to do that, you want to watch your compost method really tight. And then I might not put that places where I'm not wanting those weeds, but, it should reduce it or eliminate it. But I can't promise you that those weeds won't come back because there's always a weed stock or a seed stock somewhere. So it's hard to say if it's the compost or the seeds that were in that soil again. Because the weeds that were cut, all those seeds are falling in the soil now. So those weeds are going to proliferate either way.
Right. Okay, last person was saying compost at home. Anything you'd say starting the compost at home in a plastic bin? She's got
so composting at home is challenging. I don't even compost at home, but I have a green bin. But I would say that the thing about composting on a small scale is it's a little more challenging because the microbes need a certain pile size to just get that momentum going. So they need ideally a 4x4x4. You can technically go 3x3x3, but 4x, it's just that extra foot adds a lot. That's kind of a large system for a home, right? If you're just producing little food scraps. So I've got this awesome I'm a judge in a compost challenge at the University of Santa Cruz, where they've tasked engineering students to develop a home composting system. And these guys don't have any experience with compost. So I'm excited to see what different ideas come out of it. But for the most part, if I were to develop my own home composting system, I would probably use worms based off of the feedstocks that my family provides or, produces from food scraps and the volume. It's just not a large volume. So I would set up some small bin that's, the surface area matches what I'm going to add per week. And the worms take it down about, actually the microbes take it down about, every week or so. So it's just a delicate balance you'd have to play with. But I think those are the best systems, and you can, keep that covered so that it doesn't smell or the rats don't get in it. Or when you put the food scraps down, you cover it with finished compost. That's a really great way to keep the flies and the other critters that want to get in there. They don't even notice it's there. And then the worms underneath, they can work their magic. And then that compost on top provides that microbial pressure to also keep the food scraps breaking down.
Awesome. And where would you say for people to reach out and get these worms? Red worms for
question. It really depends on how many worms you need. So I will say that there's a general rule for a worm system. You want about 1 pound of worms per square foot. And the reason for that is, it seems like a lot. Well, the reason for that is because in the system, worms are, traveling around, but if you don't have enough worms, they won't bump into each other enough. And you want them to bump into each other so they're reproduced, right? So you have more worms. So starting with that volume gives them the opportunity to hey, check it out. I see you, and do the things.
Awesome. All right. Well, thank you so much, Doug. And thank you for, this has been a fantastic presentation. Thank you for those of you who have stuck around. And just know that in the next couple of days, we will be sending up a follow-up email with the recording of this. So please share it with the people you know. I think this, like we're learning here, the more that we're generating, action, or, we can be working together as community in this project, and also just getting it more local for those of us in San Mateo County, which is the majority of us who are going to be watching this, kind of be helping to move this more localized. And the next presentation that we have will not be until August, but we do have some work days where we're going to be speaking of carbon, getting out into the open space and making our marks. So please, keep up with, we'll have a couple of emails coming out in the next couple of weeks to share what'll be coming up next. But thank you again so much, Doug Millar, for making time to share this information with all of us.
You bet. Thank you so much for having me. And my email is up on the slide there. So if you need to reach out, please do. And I thank you very much for attending. Have a great Saturday.
All right. Great Saturday, everyone.